In this video, the goal is line tracer number 2 code, and we're trying to look for to find the how to find an R curve, which is this kind of curve node. And so basically, curve branch, do a right turn, right? So to curve, the corner judging time for the dial corner, they have certain timing that they have. Also, the time to after detecting a curve and to go forward how long. That means we're detecting how to go forward with how long. In order to pick up again, they define some other parameters, some other time. So these timing, depending on your situation, you may have to adjust also. That's another key application. So in this line of code here, basically remember this section here, that's L node forward, taking care of this job. And then this job, this section of the track here, that's L node L turn. And then go on, take care of this part here, L node L turn. And then it go here, you take an R node. But for an R node, we want to go forward a little bit more so that lined up, we're lined up here. At that time, we had to figure out, oh, can you detect an R or curve branch here or not? Because it will trigger, you can see that 4 is here, but 5 and 6 probably involved because there's a branch over here. So that's a function of firing a curve branch is curving on the right. And also at that situation, because if we want to follow this line here, that's a right turn. So what this job is, find an R curve branch, but keep on going forward until you reach about here. You pivot the right to line up if you're here. Essentially, that kind of the strategy. So let's look into what the R curve branch forward means. Let me roll down. So it's about 563 here. Let me scroll down the code here, so you can see some of it on the same time on the screen. Left curve, here we go. R curve branch forward, right here. So because so this function, it starts setting up speed for curving and change the speed. And then it detect the black, called DetectBlack. I mean, it get fresh, brand new data from black 1 to black 7. And what it does is it keep on going to a loop while. And here you can see that the left wheel is set up maximum and the right wheel is slowing down a bit. So that means it's gonna curving to the right. It go forward, but kind of curving to the right. And it say as long as black 6 and 7 see black, which means the curve are over here like this, keep on hanging right. And they have this code here, but I found out that this while loop was not really needed. And in my piece of code, I commented this one out, and the code still behaving pretty much normally. But this next one here, that is more important. And what it does, with this function here, you can see the action mainly is what? Left wheel maximum forward, R wheel is 6. Okay, and all left, so all the left wheel are a maximum speed, and the right speed is wheel speed is slow. That means it can keep on hanging to the right essentially. So it's a looping as long as 7 see white. So 7 is over here. So because they know the curve is going to go like this, 7, you're going to see the white piece of paper all the time until 7 start hitting this next piece of the track here. So this is the reason why they have a loop while black seeing white. I mean, it's okay, keep on turning right. And then you can see that if it say that, oh, 6 didn't see right either, keep on going very high speed, okay? And because it's still far off. If 6 starts seeing black, that means the 6 part starts seeing some piece of the black up here of the track, and it won't trigger this one. It goes. That means 5 should be coming closer to the this piece of black line. So you can see it going fast and then slowing down a little bit straight up here. So, but it could be too much. So if black 3 don't see white, that means the line 3, which is over to the left side of 4 here, starts seeing black. That means it's reaching this corner here. The track, there's some black track on the left now. They reverse a little bit. So the right wheel maximum speed, they slow down the left side. So let's do a quick left here. Finally, as long as 7 still don't see any white paper, the final else for it is hang a left, and then keep on going some more, but high speed. Else, that means it pretty much this situation actually start out at the beginning here. Eventually, this loop will end. That means black 7 will see 1 now. That means when this 7 here just barely see this piece of black, that's when this loop while will finish. And then it go on to the next phase, where now it's like this. So right now it's 7. We know 7 for sure seeing black now. So we wanted to check to see as long as 6 have not gone into the black area yet. So what it does, you have this loop. So you're still going left, forward, you're slowing down a bit on the right wheel speed because you're almost there. So slowing down a little bit. So you've been going until 6, sensor 6 get into the black line, and it's pretty good time to go straight now. So when it's ready to go straight, we call the straight speed to change the speed. You can see that both left wheel and right wheel are on maximum, and they're going forward for the corner forward time, and they're going only straight for about 0.4 of a second. At that time, it finish our curve branch forward, it returned from that curve, and the bot essentially roughly in this situation now. So you can see the next thing what to do is it need to pivot to the right a little bit to straighten itself up. That's why I just pivot right to line up, and the wheel will be lined up with this part, and it's ready for the next maneuver. For the diagonal, you can look for them. Let's see. That's good. Here we go. So you have diagonal corner, similar design. If the diagonal and you need to do a right turn, you find diagonal corner, you follow it and you pivot right. So I leave that for your own work, and you can define that on your own one.